Okay. All right. So first of all, if you have your graph out, that's great. Have your graph paper out. Have your notes out. What we're going to talk about today is relationships and of numbers. So this is, again, this is a part of the first section and the second section where we're graphing still. I know that's kind of the main part. We're graphing, you know, functions, polynomials and stuff. But the idea is that this second section has this one thing where it's types of relations. So it's a way of displaying data. Display data. Okay. So relations, we're displaying data on this. There's a couple different ways to display data. Number one, it could be in coordinate form, which we're pretty much used to, but I just want to make sure we'll do an example of this. Coordinate form is when you actually have individual coordinates, but you have them written in a set, so it's kind of mixing two different things together. It'll probably be pretty familiar once you see it. After we do the coordinate form, number two, from coordinate form, we're moving on to graphing. We can go immediately into a graph, like a traditional coordinate plane, if you will. I'm going to write that coordinate plane. All right, so from the coordinate plane, that information can go into something that I don't know if you've ever seen before. It's called a mapping. Mapping is a way of displaying data to show trends. It's one of those things like they would use it in like a news broadcast, especially in like election time. It's a way of not skewing data, but it's a way of like visualizing where people are like going towards like politically and stuff, and they show arrows and stuff. So it's a more visual representation.
May I have your attention, please? The cheerleaders are going to be riding with the band over to the elementary pep rally. So please desist them at this time to go on the bus.
Perfect.
Thank you.
Okay. Now, the fourth type is called an inverse. And I should use green. The inverse is the one that we're going to spend a lot more time on in the later sections. I think it's like the last section in chapter 1. It's like section 1.7 or 1.8. Inverses for functions are way more complicated than you think. Like today, what I'm going to show you is something really, really simple, like the concept behind it. But when we get to that later section, there's like a ton of math that's involved with it. Like some really actually complicated stuff. So I would say like that would be, like in the later sections, this would be probably the more challenging thing that we'll have in chapter 1. Everything in chapter 1 is pretty basic, it's pretty easy going, but yeah, that last section can be kind of rough. So we'll try to take our time on that. But today's the intro of like what it is, like the broadest concept of it. But these are the four forms. I want to go through these today. This is a way of displaying data so you can have it in different forms. There is another one, there's a fifth type, which we covered the other day, so I don't even know if I want to cover it today, but the fifth type is called a table. You guys already know how to do tables. The X, the Y, you put your numbers down. We've done that before. If we need to, we can cover that today, just to explain the rules on it one more time. But my goal is to go through the first four. If we have a little bit of time, we'll do the fifth one, and then that's it today. If we're not getting homework today, I was planning on, but I'm not going to do that to you. It's homecoming day. So let's go to the coordinate form here. Coordinate form is anytime you have coordinates and they can represent any data set that you have. So if we're doing like a project and we're trying to collect data over a certain measure, maybe you're collecting data so at like 1 foot, a bouncy ball bounces 15 times. Like it's really bouncy, just 1 foot, just bounces until it stops. At 2 feet, it bounced 20 times. At 3 feet, it bounced 22 times. At 4 feet, it bounced 24 times. And you know, you have this big data set and you can kind of go from there. These are coordinates, right? It's normal things where you have a number that you're in control of and a dependent, which is the outcome you're looking for. That's really the big thing that I want you to get from this. This is the independent. It's the independent variable. And this is the dependent. So if you're doing like a project, maybe in this class or a science class or something, The independent is the thing you're in control of. So like in this example I made up, it's like you're dropping a bouncing ball from like certain heights. You're in control of like where you drop it from. But then the bounces is totally, you're not in control of that. Like you're just looking and counting, okay? This is a curve basically.
Mr. Ward, sorry to bother you. What's the convertible situation today?
We have 3 out front, we're waiting
But I mean,
for,
do you need me to drive or not?
yes, if you can. If you don't want to, it's fine.
No, that's fine. I just gotta run, I've gotta run a bus to the band. Kevin needs me to run
Okay.
a bus over, so
Oh,
I
okay,
gotta take the band kids at 1:30.
So we'll just say you're good, you just do your band thing.
Okay, good,
Okay,
because Kevin's
yeah, that's too much for you.
short, so.
Too much.
Okay, sounds good.
Yep. All right. So, independent, dependent. So, yeah, so it's pretty easy. Now, the one thing I talked about a little bit earlier was how you actually write it. Like, these are coordinates, but the idea is that you're supposed to write it like this. I know this is really picky, but coordinates, like when you're writing a data set, you're actually supposed to put a curly brace like a set, and then write them like this. And you put commas in between these, 2, 20, comma 3, 22, comma 4, 24, comma da 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 da, curly brace, whatever your data set is. And how they tell you to organize it is that whatever your independent number is, so the independent number is the number you're in control of, the x number, right, the x coordinate, you're supposed to organize them by those. That's just like a little thing you're supposed to do. So like I'm going least to greatest. That's how all sets are supposed to work. The independent number is how you're supposed to write it first. So it's whatever number is in the front. Does that make sense, like how you're supposed to write coordinates properly when like you're writing a data set? You're supposed to use curly braces and actually do that thing, organize it, and move them around. Okay, now a graph. You guys are very comfortable with graphs. You actually have a graph in front of you, right? That you could graph any data set. Graphing, on the x, y axis. So here's your x-axis, here's your y-axis. 1, 15. So let's say this is 15, boom, there. And then you go to the next one, 2, 20. Here's 20, boom. The next one is 3, 22. And then 4, 24. And you can kind of see what's happening here if you get kind of a view. Now, the thing that I want to talk about is that when you're displaying data with a graph, this is the part where it can get really like controversial because you probably talk about this in like history classes and economics and whatnot, but data can be like skewed a very, very specific way, so it shows a trend that you wanna try to prove. So like on this set, the thing that would worry me if I was looking at a newspaper at this data set is like, why did they start at 15 here? Like this gap is not the same as the other gaps. Like there should be like, this should be a 5, a 10, then a 15, then a 20. This is like, it's skewing the data visually because of that weird set. Now if they do something like this, like that means they're cutting the graph right there. Like it's supposed to be equally spaced. They're cutting it off and just sliding the graph down so you can see it better because it would have been off the grid. Because they don't want to print the whole graph because all the data was up here. That's fine. Like they're actually showing that this is being cut. But if they don't, then they're trying to deceive somehow and show a trend in data. Like that isn't supposed to be there. It's like when companies show this, like they show bar graphs and pie graphs, but the graphs don't actually add up to be 100%. It's a skew in data. Like they're trying to show something. It happens a lot in politics, but it's one of those things like when you display data, usually graphing is one that a lot of people wouldn't catch it, or it jumps by random numbers, or they're not equally spaced. They're trying to prove something that isn't really real. So that's just something that you need to be kind of cautious of, especially if you're in like a science class. Like to show the data, you need to be equally spaced for all the numbers, unless you're going to show that little squiggle showing that you're cutting the graph at a certain spot. Okay, any questions with a graph and how it could be skewed? I think you guys know how to do graphs. I mean, you've been doing them for the past week almost, drawing what, 5, 6 different pictures for me, different ways of drawing them. We're still going to be drawing, like that's that first time, we're still going to be graphing stuff, we're still going to be plotting, so I just want you to make sure of it. Now, mapping. Mapping is one of the things that I don't know if you've ever seen it before, so I'm kind of worried about it. I'm just going to use the data set we have here, but I'm going to do a mapping. Okay, for a mapping, it's going to have two bubbles, like that, two bubbles. One is the X, one is the Y. What you're in control of, independent versus dependent. And you put the numbers least to greatest. So you will have to reorganize the numbers. So in my case, least to greatest is 1, 2, 3, and 4. These are the heights I was dropping the bouncy ball from. If there's any repeating numbers, you don't put them. So if, like, let's say you did a secondary test, like somebody, like, you dropped it, you counted 24, but your neighbor was like, hey, I don't think it did it right. I think it got caught on something on the floor. So you remeasured the fourth height and maybe it bounced 25 times. So you remeasured because maybe it hit something on the floor that kind of skewed the data. You don't need to put 4 twice in this data set. Even though you have 2 sets of data for the number 4, you only put 1 of them. Does that make sense?
Doesn't matter which one.
No matter which one. So even if like the number 1 repeated, you don't need to put it twice. Just put 1, 1, 1, 2, 1, 3. It's whatever numbers you have. Okay? Now on the other side, you put the Y numbers in least to greatest order. So even if they're all over the place, you reorganize least to greatest. So 5, 20, 22, 24, 25. Okay? So that's what we have, and then you're gonna, then what the mapping tells you to do is draw arrows. So you would start at the independent side with a dot. It's like a ray. We're drawing a ray, or a vector, if you will. You're drawing a ray from 1 to the number that's matched to it. Well, it's matched to the 15. 2 is matched with 20, so this is pretty straightforward. 3 is matched with 22. And then the 4 has 2 rays because we had 2 different data sets. So it went to 24 and it went to 25. Okay, so it had 2 different data trends. Well, the idea here is that this is not a function. Does football players need to leave or something?
No, they're going in the grand, so. I know.
How long is period? I was told like 8:45 or something.
Half an hour.
I'm not sure.
8:45. Okay. They'll probably come on announcements like they did with.
Well, we're supposed to end at 9, so
Yeah.
it's not time.
Yeah. So that's weird. Are packing in there. All right.
I gotta see what the page, it's about 8:45.
Okay. They'll come over the announcements then. All right. So does everyone see how the mapping works? Now, even if the data, let's say you did another data set where you did a 5th one, but it also bounced 25 times. So you did a 5th one and it bounced 25. So then you have a 5 and it's going to the 25 and you have the arrows merge. That's a mapping. It's very specific. The arrows have to be very straight. You don't want to do curves, nothing like that. It has to be a perfect ray going straight like an actual line. And then the data. One thing that we're going to be eventually talking about, like the 2nd section, 3rd section, like on Monday, and Tuesday next week, is this a function or not? Would this represent a formula we could actually come up with? There is probably a formula to it, but it's not a function, because the definition of a function, of like something you can actually graph, is that for every element in the domain, there should only be one answer in the range. Every element of the domain is matched with one element in the range. This one failed. 24, you skewed the data. When you guys remeasured, that threw off the data, so it's not a function anymore. There's probably not going to be a way to actually come up with a formula for it. That would be linear or based on a curve. So it's not a function. So that, because of that number 4, you got 2 different data sets. That shouldn't happen. It's like if you're trying to type a number in a calculator and you hit enter and it tells you 24, but you type in the exact same thing, you hit enter and it tells you 25. That should never happen. You're typing something in wrong, you didn't clear it out all the way. The calculator shouldn't make a conscious choice of which number to show you at any random time. But that's a mapping. Some people have never seen it. How many people actually have seen a mapping before? Okay. It's usually used in political polls. When they show like certain voters, like what they do, and I hate when they do this, but it's on like a major broadcast, they'll show like people by race, and then they show the candidates and where people are voting and they draw arrows. I hate that. That should never happen. That's the most racist thing in the world I've ever seen. Okay? It's just one of those things, they're trying to show trends to sway data. And it's just one of those things, like it's very visual because you can see the arrow where people are going towards, but it's so controversial because they're generalizing everything. They're throwing out any concept, they're trying to display something. There's some hidden motive there, and it just drives me nuts when I see them like a political ad. So just be cautious of that. That's usually where I see it. It's in a news broadcast for a political campaign, or when it's during election. Question?
News or some?
Yes, ma'am. Okay. So that's a mapping. So it's pretty straightforward. Let's talk about inverse today. Inverse. I only have two more here. So inverse. This marker's dying on me here. All right. So inverse is when you take all the coordinates and you simply switch them around.
Yep.
Pretty easy.
Bunch of football players just down the hallway talking to B. I don't know if like that means anything with you.
I'm just gonna assume I should probably do.
Okay. So,
Do you want me to go to it or not?
what?
Do you want me to go to it or not?
Probably, yeah, go check. Okay. If you need to go to the elementary, you probably should go. So, if not, you guys can come back. Okay. Good luck. Have fun. Kids are gonna be wild.
The shrieks get me every time.
All right. So, inverse, you take the coordinates, you merely switch them around on it, okay? Now, why we'd ever do that? This is something I said we're gonna get in like section 7 or 8 in chapter 1. There is a way where instead of, using the thing you're in control of, like the independent, like in our case, the bouncy ball's dropping from 1 foot, 2 foot, 3 foot kind of thing, where you actually look at going backwards. And so you start with the fact of like, I want this ball to bounce 50 times. What height do I need to drop it from? And that's the hardest part about this because, on this type of data here, you saw it was kind of a curve. Will it even reach 50? That's a potential. And so some functions don't have an inverse. Like you can't actually switch the data around and find an actual answer for it because it may not work. You can have a potential, but it won't work perfectly. And that's where it comes down to like looking at a mapping and looking at your data sets and looking at a graph to see, is it even possible? Like right now on this one, it may be possible, but we have to look at more data to see if 50 will actually work. Will I ever hit 50? Because maybe this thing has a limit. Like the ball will only bounce so many times because of the material itself, or gravity doesn't allow it, or the weight of the object. So, and you have to look at kind of this thing, is it reaching a limit? And that's like a concept that we get in calculus. All right, questions on what inverses are right now. We're just switching the data sets. We'll get to the more complicated stuff later. Tables, you guys know it. We've done that before. Tables, you just take your data. You take your data and you merely organize it by X and Y. So you put it down 1, 2, 3, and 4, and 5. And if there's repeating, you can actually put them on a table. And then the numbers go straight across. And these numbers don't matter, but they have to be matched up with the answer that was provided. So this is 24, 25, and then 25. The answers go straight across, and you even put repeating. It's not like a table, or it's not like a mapping where you throw out the repeating ones, you just draw arrows. This one, you don't need to draw arrows, by the way, but the answer should be directly across, and they have to go least to greatest for the X's. The Y numbers can be completely randomized. So it doesn't matter the order. So if you switch the 24 and the 25 around, it didn't actually matter. As long as these numbers on the independent side were in least to greatest order. Questions with the 5 data sets. Okay, we're gonna do a lot more with this stuff. It's like the intro day. I'm hoping you've seen this stuff before. Like, if you haven't, it's a good day to see it. You get to see it at least once in your life before we actually get to the more complicated math. Okay, questions, comments at all? All right, we're done for the day. Nice and easy. Well, I have about 5, 6 minutes left here, I think. We're out of here at 57.